The energy settings in Revit help designers make basic assumptions for early-stage energy analysis in Autodesk Insight on the cloud and systems analysis within Revit. They also inform the created energy analytical model for this analysis. In this video, we'll go to the energy settings in Revit to configure our project. We will also configure the space types for the various spaces we created in the previous video. So start by opening the Revit model you created in the previous video or energy settings in the chapter 1 exercise files folder. At this point, launch Revit and navigate to the exercise files. From the chapter 1 folder, open this file energy settings which I have here. From the project browser, scroll down to schedules and open this out of the box schedule, space add.s schedule. Then from the properties browser, edit fields and add name for space names. Use this arrow key here to move it up to become the first column in the schedule. So here you can see the various spaces in the facility. Now we need to set their space types to the standard HVAC space type. So to do that, beside the space type parameter, click the small ellipsis button to launch the space type settings, then pick the corresponding space type. For each space type, you'll find the standard HVAC settings, which are all adjustable. For example, we can change the occupancy, lighting, or power schedule for the various space types, or we can also change the heating or cooling set points and whatnot, or even create entirely new space types to meet the project's unique requirements. So with these values in mind, let's configure the energy settings for this facility. To do that, go to the Analyze ribbon and from the Energy Optimization panel, launch the Energy Settings dialog. From here, we'll configure the various settings. The first we'll have here is the Energy Analytical Model parameters. So here, set the mode to use conceptual masses and building elements. This is the default and is the preferred option in most cases. Next, check use only elements visible in current view. And this ensures that only visible elements in the default 3D view inform the energy analytical model. Then confirm that the ground plane is natural ground level. This parameter informs Revit of the level below which the energy analytical model surface is in contact with the ground for heat transfer. Next, set the analytical space resolution to 152.4 mm, which is 6 inches. And this is the minimum gap between Revit elements to be ignored in identifying energy analytical model spaces. This primarily influences the energy analytical model's accuracy and also the processing time, and this is the minimum allowable value. Next, set the analytical surface resolution to 76.2 mm, which is 3 inches. Now, this value should be less than the smallest dimension of any surface to be included in the energy analytical model, and it is also the minimum allowable value. Next, we'll set the perimeter zone depth to 0, and this is the distance to measure inward from the exterior walls of the facility to define the perimeter zone. This setting is preferable when using a conceptual mass without internal walls to define the interior spaces of a facility. And the assumption is that the heating and cooling loads of a building's core differ from the perimeter as it's not directly exposed to external weather conditions or daylight through windows. So we'll leave this to 0 because this is a small facility, not a big one with separate perimeter zones. Also, we already have a detailed architectural model in the project, so we don't need this. Then we'll turn off the perimeter zone division since the zone depth is already 0. For these two values, we'll leave them at default, but basically the average vertical void height threshold is used to avoid applying unwanted thermal loads and properties to small analytical spaces like ceiling voids. So when an analytical space average height falls within this threshold, it will automatically be assigned to unconditioned zone equipment and excluded from systems analysis. The same applies to horizontal void/chase area threshold. When an analytical space area falls within this threshold, it will also be assigned to unconditional zone equipment, just like for average vertical void threshold. Finally, under the energy analytical module group, set the reports folder part 2, this course exercise files folder, so you can access the systems analysis reports in the exercise files when we generate it later in this chapter. Next, open the other options for more advanced energy settings. The first we'll have here is the detailed model parameter group, and this applies to conceptual masses, and they are typically graded by default. To modify this, we'll close this and come back. So for this, we'll set our target percentage glazing to 30% for this facility, and the target seal height to 600 millimeters. Then we'll check this glazing is shaded. And we'll set our shade depth to 225 for a standard 1.5 window. This is 15%. Then for target percentage skylight, we'll leave it at 0, and also the skylight width and depth will be grayed out because we don't need this in this facility. Then we'll move to the advanced group. Here we'll set the building service to fan coil system, which is what we are using for this facility, and the building infiltration class will set that to medium. We'll leave the other parameters under this group at default, as they mainly apply to Autodesk Insight. Now we'll move to building data group. Here we'll set the building type to single family because this is a single family residence. We'll leave the building operating schedule at default and set the HVAC system to 4-pipe fan coil system, chiller of 5.96 coefficient of performance, boilers of 84.5 efficiency. For the outdoor air information, we'll set the outdoor air per person to 2.4 liter per second and outdoor air per area to 0.3 liter per second dot meter square. So this is just an average value for a living space in a single family residence based on ASHRAE standard. We'll leave the export category as spaces, and then we'll move to material thermal properties group. There are 3 options here. First, we have the conceptual types. So analysis properties are generated from the choices that you make here by default if you don't override them by the other 2 options. The second option is schematic types. So if you wish to get more refined, you can override the values in the conceptual types by checking the override box for every desired category, and then you choose an analytical construction from the drop down. So I'll come back here in a bit. For the detailed elements, when you check this box, Revit uses the thermal properties of the materials assigned to the building element. So at early stages of a project, you really don't want to get this detailed. So at this stage, we'll use the following construction to refine our assumptions. So we'll override most of these categories. We'll start with the roofs. So here we'll be using wood shingles, wood sheeting, R19, bath insulation, gypsum board. And for exterior walls, we'll be using structurally insulated panel SIP wall 4.5 inches. For interior walls, we'll be using frame partition with 1-inch wood. For underground walls, we'll be using standard wall construction -C. For ceilings, we'll be using 1/2-inch plasterboard with TG, 1/2-inch plaster with TG boards on 16-inch joist centers. Then for floors, we'll be using 2-inch wood deck. For slabs, we'll be using standard construction -B. For doors, we'll be using wood panel. For exterior windows, we'll be using low emissivity double glazing domestic. Then we'll leave interior windows and skylights unchecked since we don't have that in this project. Then we'll set the shading factor for exterior to 0.15, which is 15%. Then we can close all this. And that's it. We have configured the energy and space settings for this facility. And now we are ready to start creating analytical systems for our systems analysis. So make sure to save this file ahead of the following video.